Hello, right. This one will look at area and we'll use sort of square shapes, squares, rectangles, and all that kind of things, and triangles. We'll do the circles in another one. Triangles, squares, and triangles. Right, squares and triangles. Where are we going with this? So, now, don't get this mixed up with perimeter. Here is a square, 4 centimeters. Yeah. Now, we know from previous lessons that everything is going to be 4 because opposite sides of a square is the same, are the same. Now, when we do the area of a shape, we multiply two adjacent sides. So we multiply adjacent sides. Now I know that I've just happened to go on a 4, haven't I? So if you do the perimeter, you would add all the 4s up together and get 16. But this time we've got to multiply for area. And we're going to go 4 times 4. This 4 times this 4. And that will equal 16. And here's the difference. Because this is an area, we have to put a little 2 on there. And that says it's squared. So it's 16 centimeter squared. Now the reason why we do adjacent sides, but if we have a kind insert something, you draw a shape. No, oh, I don't like that. All right, okay. So say that's 10 centimeters, and that's 15 centimeters. Yeah, it's a rectangle. It would mean that that was 15 and that was 10 because the opposite sides are the same as each other. Now, if we multiply these two together, we go 10 times 15, which equals 150 centimeters squared. That's it. You just multiply two different sides, two adjacent sides together. I'm just going to have another go at that to see whether I can actually draw that's better. Yeah. Um, Call that 20 meters and that 5 meters. So to find the area will equal 20 times 5, which is 100 meters squared. Don't forget the little 2. Now, imagine that this is 400 centimeters. You can't go multiplying 20 by 400, so the units must be the same before you multiply. Now, it doesn't matter really whether you change them both to centimeters or both to meters, but when you get here, have a look at there might be an answer line down here, and it might give you a clue to what it's going to be. So if you change these to centimeters and multiply them all up, you think, it's the wrong ones, yeah? So that's the clue. It's going to be in meters. So I change this to meters. So we did 400 divided by 100 this time, which is 4. So now we've got 20 times 4, which equals 80 meters squared. So make sure you get the units the same. Now, to complicate things, as we did with perimeters, you might get a shape something like this, where you're going to, let's say, call that 10, call that 6, let's say everything centimeters, funny old centimeters. We call that 7, and that one's 5. Now again, what we do is the same when we were doing perimeters, is we need to chop this shape up into rectangles. So I'm going to go across there and call that A and call that B. Now to the area of A, we've got two adjacent sides, but we haven't really got any information on this little bit alone, but we can work it out, because if that's 10 all the way across and that bit is 6, this bit must be 4. And if this 7 from top to bottom and that bit is 5, that section, this bit must be the difference between 5 and 7, which is 2 centimeters. So A is going to be 4 times 2, which is 8 centimeters squared, and B is going to be 5 times 10, 5 times 10, which is 50 centimeters squared. Therefore, add the two together, and the total is 58 centimeters squared. That's what we do when we've got bits added on and they're a bit awkward shapes. Right, so let's have a look at when we've got a bit taken out. Um, uh, Not to scale, as always. Yeah. We'll call that 1. Right. All in centimeters. Yeah, that's up to do with that one. So what we've got, we can do this, approach this the long way round by doing that and that, so that we get A, B, and C. And you work out what A is, what B is, what C is, and add the 3 together. We'll do it this way first. So A, that's going to be 6 over there, isn't it? So A is 2 times 6, which is 12 centimeters squared. C is 2 times 6 again, which is 12 centimeters squared. And B, this little bit in the middle. Now, if that's 1 there, and that's 6 there, that means this dotted line, dashed line, must be 5. Right. And what about this bit in the middle? Well, it's 10 all the way across. There's 2, there's 2. So the difference of that one, so 10 minus the 4, which makes that 6 over there. So we've got B is 6 times 5, which is 30. And add them all up together, and we get 54 centimeters squared. Bit of a long way round. Is there a better way? Yes, there is. Right, so let's try and go back to where we were and get rid of all these bits. There, there, there. Okay, right. Okay, a different way round. We could imagine that, and if that was filled in, we could work out the area of the whole thing, which would just be 10 times 6, which equals 60 centimeters squared. So that would be the whole thing, not with that bit not taken out. So if we can work out the area of that little bit, take it away from 60, we should get the answer for this sort of big U-shaped. So this little bit was 1, and all we need to do is find this one. Remember, that was 10 all the way across, so we take away the 4, so that was 6. So if we do 6 times 1, we're equal to 6 centimeters squared, and we do 60 minus 6, which is 54 centimeters squared. So it's a bit quicker than this green way, but never mind, it doesn't matter. Right, so let's have a look at some squarey check questions. That's a triangle. We'll come to that in a minute. Right, so let's have a look. Also, we've got decimals in here. So what we're going to do is pause it, have a go, and then see if we get the same. We're going to chop this up into A and B. So area A is going to be 4.4 times 3.2. 4.4 times 3.2. And area B is going to be 8.1 times 2.8. Right, calculator out. So 4.4, no, that's 4.4. 4.4 times 3.2 is 14.08. 14.08. And this one is 8.1 times 2.8, and that is 22.68. 22.68. Add the two together and we've got the answer. So 16,763. 37.76 centimetre squared. But this one. Yeah, let's do the bit where we're going to do the shorter way. We'll work out the area of the whole thing and then take this away from it. Okay, so the whole thing is 11 times 13. 11 times 13 is 143 centimetres squared. Now we need this middle bit. So we know that that's 5 there. We need to work out this one. So it's 13 all the way across. Take away that, and that is 6, so that makes that 7. So 7 times 5 is 35 centimetres squared. So if we do 143 minus 35, we get 108 as the answer, centimetres squared. Oh, good. That's rectangles, squares, and this is called complex shapes, I suppose. A bit more complicated. Right, now let's do triangles. So triangles. Now, lots of different sorts of triangles. We've come across these before. We've got the right-angled triangle, where there's a right angle. We've got an equilateral triangle, where all three sides are the same. And we've got an isosceles triangle, where just two of the sides are the same. And it's the same formula to remember for working out the area of a triangle. Now, if if I have a sort of rectangle shape, and this is this is 10 and this is 8, then the area of that would be 8 times 10 equals 80. Well, we'll call it centimetres squared. Whoops, centimetres squared. Now, we're going to make a triangle now. I'm going to do that. Now, if that was a piece of paper and we cut it corner to corner, we've cut it in half. So the area of the triangle is half the area of the rectangle. So we shall call this the height, because now we're just looking at the triangle, and we'll call this the base of the triangle. Yeah. So we've got a triangle like this. There, a lovely big yellow triangle. So the base of the triangle is here. The height of the triangle is this. Now, one thing to remember is vertical. It must be the vertical height, not any slopey sides, as in here, as in there, or as in there. It is the vertical height all the time. Now, so the formula for the area of a triangle, remember, it's half the size of a rectangle. So we're going to have the half times the base times, well, I'll put times in there, times the height. Yeah, so if we just did base times height, we'd work out the rectangle area. If we do half base times height, we work out the triangle's area. And that can be abbreviated to half BH. So area equals half BH. And for this particular triangle, half times the base, which is the same as the top, which is 10, times the height, which is 8. So a half times 10 is 5. 5 times 8 is 40, which you can see is exactly half of that. Now, when you've got all multipliers, you can go 8 times 10 is 80, times a half is 40. A half times 8 is 4, times 10 is 40. You can go backwards and forwards any direction you like when it's all multiplied. Sometimes it's easy. If you had an odd number, then you go, yeah, if you had something like this, a half times 9 times 4, yeah, you go a half times 9, which is 4.5. Then you've got the awkward bit of 4.5 times 4. A bit complicated. But if you go the other way around, you go, well, 4 nines are 36, and a half of 36 is 18. So sometimes it's easier to go the other way around. So there's some triangles. Did I get a triangle? Yeah, let's have a look at we do a couple of triangles. So we do the right angle triangle first. Put that in there. And this is 8 and this is 7. Yeah. So the area equals half the base times the height, which equals a half times the base, which is 7, times the height, which is 8. Now 7 eighths are 56. Half of 56 is 28. So we've got 28. They'll call it centimeters squared, right? So that's fine. Now if we have sort of an isosceles or an equilateral, there's 5. We must be given the vertical height, which we say 7, and sometimes they're put on here a 6, something like this. Just to throw you off the track, ignore this bit. We don't need that bit. We need the area to be half the base times the vertical height, which is a half times 5 times the height is 7. Now I'll come backwards on this. So 5 sevens are 35. Half of 35 is 17.5 centimeter squared. Okay, so there's a triangle. I've got one question on triangles, I think, is there. Find the area of the triangle below. And you see they've got the vertical height. So the area equals the half, the base, the height, which is a half times 7.2 times 3. Now, if you're going to bang this into the calculator, know that a half is 0.5. Yeah, 7.2 times 3. One of those in the little table of you must remember the equivalents of certain fractions and decimals. Yeah, and then otherwise it's just you're complicated. 5 times 7.2 times 3 is 10.8. 10.8 centimeters squared. Okay, so that's that one. And that's triangles and squares. And so we will have a worksheet on this, no doubt. And don't worry about that. Yeah, worksheet on this. And we'll see you in the next one, which is most likely going to be circles.